right. Yeah, let me just read through the notes here. It says none of the 6 trig functions is 1-to-1. What that means is that with a trig function, our graph is continually going to repeat, which means that it will not pass the horizontal line test, which means that its inverse will not be a function because the graph will do this, right? It'll just continue to it's like taking a function and kind of flipping it sideways, basically. But we can still call these an inverse. We call the inverse a function as long as we restrict the interval, right? Where we say, okay, we don't want to have the graph continue past this point, and then this graph technically continues forward. But if we stop our domain, then or stop the range, then our graph does pass vertical line test. So even though inverse trig graphs are not quite functions, we can force them to be a function if we give it restrictions. Arcsine and sine are inverse functions. That means that arcsine of sine of x and sine of arcsine of x is equal to x. So inverse is not quite the same as reciprocals, right? We don't treat arcsine the same way as cosecant, right? So cosecant is the reciprocal of sine, but arcsine is the inverse of sine. So inverse is where you swap the x and y and you solve for the new y. Okay. Now with these inverse functions, we don't really have to worry about too much about how they're graphed or what the graphs look like. We just have to understand how to work with them algebraically and how to involve their derivatives. Okay. So again, there are 2 notations that you might see. You might see arc trig with that -1 notation. That's not an exponent per se. We're not really raising that sign to the -1 power. That's a special notation to indicate that it means arc trig or inverse trig functions. But you may also see arc sine or arc cosine or arc tangent. That means the same thing. Okay, so these are very special notations. So we don't want to treat that as raised to the -1 power. Even though that was a 2 there, then you would raise that to the 2nd power. So this is not, it's just a special notation, not numerically. We don't treat it numerically the same way as other numbers. Now, these derivatives look really complicated, and it looks like a mess to have to memorize. But I do want to point out that these are really only 3 rules. These look like 6 rules, but these are only 3 rules. What do you notice about arc sine and arc cosine? Except for the fact that one's positive, one's negative. And same with arc tangent, arc cotangent. Same with arc secant, arc cosecant. If I know these 3, then I can copy down these 3 and just put a negative in front. Okay. After we learn how to use these rules, then I want to spend time helping us figure out patterns that can hopefully move us towards memorizing these rules a little faster. But I know that right now it looks a little intimidating since this looks like there's so much involved there. Okay. Let's start off with example 1 here.
These are being memorized too.
They do for the test. Yeah. Okay, let's just start with some review of arc trig or working with arc trig. So what it says, find the tangent of arc cosine of √2/2. This means that you want to find the tangent of the angle whose cosine is √2/2. So anytime you see this arc cosine, arc trig, this is really a way of rearranging the fact that this is referring to a theta. This is referring to the theta value. Okay. So if I step to the side here, what this is really saying is, what will the cosine look like when the ratio is √2/2? Okay. That's what this is saying. This whole thing represents theta, but we're able to represent theta in a way that is saying with more detailed information. Okay, so what we can do is from here, we can build our triangle. So cosine theta equals √2/2. Here's our triangle with theta. √2/2 is just adjacent over hypotenuse, right? So SOHCAHTOA here, adjacent over hypotenuse. So if I do √2/2, Pythagorean theorem, I can find that this missing side is also √2, right? A² plus B² equals C². And really, it's just a 45, 45, 90 triangle. And this inside portion allows us to figure out all the sides of our triangle. And now we just turn around and say, what is the tangent of theta? What is the tangent of theta here? Now that we have all this figured out from this inside information. Yeah. Yep. Hypotenuse, sorry, opposite over adjacent, right? Opposite over adjacent. So this is simply equal to √2/√2, which is equal to 1.
Tangent theta would equal 1.
That's right. The tangent of this theta is equal to 1. That's the answer, right? So the inside bracket helps us fill out the triangle, and then the outside is really what we're asking, we're trying to find. Okay, let's see if we can try another example here. Yes. Right. So cosine of theta is equal to √2/2. This is what really this is saying. So cosine of theta is equal to √2/2. If I solve for theta, then I can do inverse, right? So theta is equal to inverse cosine of √2/2. And again, inverse cosine means our cosine. Right. So basically, this is saying find the tangent of theta. But instead of putting theta, they're giving us more information. So they're replacing theta in for that inverse cosine of √2/2. So it's just a more involved way of using inverse.
Well, like our cosine same way as saying like the opposite of being the inverse.
The inverse, that's right. Yeah. So number 2, it says find the cosine of arc sine of 5/13. So this is really saying we know that arc sine of 5/13 really represents theta. And then if I were to rearrange this, this is really saying 5/13 is equal to sine of theta. It's just able to compress it into this form, but this is really what it's saying. Sine of theta equals 5/13. So can we create a scenario where sine of theta equals 5/13 and then use that scenario to figure out the cosine of theta? So we go to our triangle here. Let's create a triangle where this is true. Sine of theta equals 5/13. Where does the 5 and 13 go? Opposite over hypotenuse. Now, can I find this missing side here? Yeah, Pythagorean theorem, A² plus B² equals C². 12, yeah. So now that we have theta figured out, right, theta in terms of the size of a right triangle, what's cosine of theta? Yep, adjacent over hypotenuse.
So it's like a two-step problem. Currently,
It's a two-step problem, right? This inside will help us figure out the dimensions or the information about the triangle. That way we can get more detail about what is the cosine of that triangle. Cosine theta.
So you never have actual value for the data though. Like you never actually.
Right, we don't need it, right? We're asking not for theta, we're asking for the ratio. Yeah, you're right. We're not gonna, I mean, we can find theta, but that would require a calculator, and right now, we're just trying to involve ratio. Yeah.
Will always be 45, usually a case where it'd be like 60, 30, 90 or.
Right. In this case, this is a special right triangle. 45, 45, 90. This is not a special right triangle here. I mean, this is a Pythagorean triple, but that theta is not going to be a 36. It's not going to be a 36, 90 or 45, 45. But it's okay because we can still find the ratio even if it's not a special right triangle.
There are scenarios where it could be like 30, 60 more. Like,
Yeah, it could be. Yeah. But I mean, we don't have to worry about whether it's a 30-90 triangle or not. It could be 1, 1/2, root 2. Okay, let's go to the next page. Okay, example 3. It says, write the expression secant of arctangent of 3x in algebraic form. We can also do what we did from the previous page, even if what's involved with the triangle is not a real number. Even if it is just a variable, we can still do everything we just did from a triangle perspective. So arctangent of 3x, that's another way of saying arctan of 3x represents theta, right? Because this whole inside represents theta. And if I rearrange it in something that feels more familiar, I can say this is the same thing as saying tangent of theta is equal to 3x. And if I force a denominator, I can say 3x over 1. So can we create a triangle where tangent of theta is equal to 3x over 1? Right? Where would the 3x go and where would the 1 go? Yeah, 3x is opposite.
no one's
Yeah, adjacent. And then what can we do to figure out that hypotenuse? Yep. A squared plus b squared equals c squared. I want to solve for c. So c squared equals 1 plus 9x squared. If I take the square root to solve for c, c is equal to the square root of 1 plus 9x squared. But now that we have the triangle figured out, what is the secant of theta? Yep, hypotenuse over adjacent. So square root of 1 plus 9x squared divided by 1.
Can't simplify any further.
That's right, we can't go any further. And I can drop the 1 if I wanted to.
I can technically simplify the 9x squared part of it, because you can't use this part of the 1.
You're saying why can we not make that 3x?
Yeah, that's a.
Yeah, I know it's tempting to do, but why can we not do that?
It's because of the plus.
That plus sign, that's right. If there was not plus sign there, if it was 1 times 9x squared or if there's anything with a multiplication involved, then yeah, I can take the square root and not break any rules. That plus though prevents us from moving forward.
The answer, we just have the answer by itself. We don't have to say like there's no like variables. It's not like data equals that.
Right.
Or x equals that.
Right. This is just tangent. This is just secant of theta.
Okay.
Yeah. And theta is given, we're given information about theta with that arctangent 3x. Okay, there is a way for us to find the derivative of arcsine using older rules, but I'm just going to skip that because I realized that even though this is a nice way of using older rules and not having to memorize these rules, it's not efficient and it just takes too long to go through. So I'm just going to have us practicing these rules that we have above here. So you have arcsine, arctangent, arccosine, arccotangent, arcsecant, arccosecant. Now, the u value, we recognize it from trig functions in general, right? U value is just what's inside the trig function. Same thing here. U value is just what's inside the arcsine. And then once we identify that u value, then we just do what the rule tells us. U prime means find the derivative of that expression. The u value just means take the u value and don't change anything to it. And then do whatever you need to do, in this case, squaring it.
Is there gonna be any like application problems for this stuff? Or is it not?
No, it's just pure derivatives, yeah. Product, chain, quotient rule, that type of thing. All right, so example 5, it says example 4, sorry. Yeah, we'll do this using our derivative rule here. Arc sine of x. Okay, so we have the rule right above us here. What's our u value? Just x. Okay, so then the rule says u prime over square root of 1 minus u squared. So what's u prime going to be? 1. So 1 over the square root of 1 minus x squared. That's the derivative. That's the slope formula for arc sine of x.
So we're not doing like the implicit method.
Yeah, more now. All right, example 5. Find the derivative of y for y equals arc tangent of 4x. So now we have a different rule to apply. Arc tangent of u is u prime over 1 plus u squared. What's our u value? 4x, okay. So u prime over 1 plus u squared. What's u prime going to be? It's 4. Divided by 1 plus. Okay.
16x squared.
Good. So we want to make sure that we don't just do 4x squared without the parentheses, because let's remember that both the 4 and the x is impacted by the exponent. So yes, you're right. 16x squared. So here's our slope. We can't simplify.
Oh, no, use the plus.
Yeah, the plus sign. Yeah. Now, if it was just 4 over 16 plus x squared, then yes, you can reduce the 4 and 16, but that 1 plus gets in the way.
You can't simplify to 1. You can't take the 1 out of here.
Can't take that 1 out either. Yeah. All right. Example 6. Find y prime for y equals 2 arc secant of 3x squared. So arc secant is the messiest looking rule here. It's got the absolute value, but we just follow whatever the rule says. Okay. All right, what's u prime here? Well, what's the u value? 3x squared. Okay. What is that 2 going to do? Yeah, it's just a coefficient, right? It's just going to hang out in front. It's not going to go anywhere. Okay. All right. So y prime equals 2 times. Yeah, 6x, right? U prime is 6x. Yeah. Divided by absolute value of 3x squared. There's not anything special we have to do with it. We should have to kind of make sure we keep track of that there's absolute value involved with the derivative times the square root of. Yeah, we got to square both the 3 and the x squared. Technically, I can reduce a little further here. The 12 and the 3 can cancel out. If you don't reduce, it's fine. But technically, you can take away the 12 and 3. You can reduce one of the x's, but the absolute value would stay. So let me show you a different cleanup here.
You can like You get to react it.
Yeah, you can take a 3 out of it. You can take an x out of it, but if there's any variable remaining, I got to make sure that the absolute value stays. I cannot remove that absolute value.
Unless it's like a real number.
Right. If it's a real number, then yeah, I can drop it. I can drop the absolute value. All right, number 7. Y prime, find y prime for y equals x times arc cosine of 2x. Anything special here? Product rule. You see that x and arc cosine 2x are two distinctly separate expressions that are being multiplied with one another. We got to go through product rule. Okay, f prime g plus f g prime. Okay, x becomes back to f. Arc cosine of 2x. Arc cosine 2x looks a lot like arc sine. We just have to make sure we keep track of a negative in front. So times negative what? Negative u prime. Negative 2 divided by the square root of 1 minus 2x quantity squared, or 1 minus 4x squared. We don't have to rationalize the denominator. There's not much they have to clean up. Example 8. Find the derivative for cosine of arc tangent of x. What do you notice here?
Oh, there's like parentheses around that.
Mm-hmm.
Change in x of like brackets or whatever.
Yeah, but what about derivative rule? Anything special that you see? It looks like product rule, right? But it's not quite the same as. Now let me show you. If maybe yeah, chain rule. I think a good example of product rule would be this. It was cosine of x times arc tan of x. These are completely outside of each other, so this would require product rule. But this is a function inside the cosine, right? So let's think in terms of chain rule here, right? So chain rule, outside portion is the cosine parentheses. The inside portion is the arc tangent of x. Okay, let's find the derivative here. So cosine of u becomes. Anyone recognize their own tone? No. Okay, what's cosine's derivative? Negative sine of u. Right. Do we do anything inside here? Keep it, right? Okay, arctangent of x, our derivative. U prime over 1 plus u squared. Okay, so u prime 1 over 1 plus x squared. Okay, now one thing that I want you to do beyond this is that you're going to get this out of this notation and into something algebraic. So we have to create our triangle here and figure out how to get this into some rational expression. Okay, so sine of arctangent of x, step to the side here and say this is basically the same thing as saying tangent of theta is equal to x. Sorry, tangent of theta, yeah, equals to x. Okay, so create our triangle here, tangent of theta. Right, x over 1, opposite over adjacent. Pythagorean theorem. Okay, what's sine of theta going to be? Yeah, x over square root 1 plus x squared. The negative is going to have to stay. Yeah, you can go a little further in this, but this is fine. You can leave it in this form.
There's no change. We've all been there before.
Okay, if you guys can turn to, I just want to find a blank page for us to practice these derivative rules. So maybe you can, we'll use the bottom of the calendar on inside of the page of your cover here. And let me kind of walk through the rules before you guys try them. Now, you're going to organize your part trig functions the same way that you do your trig functions. Okay, so all the C functions on the right, all the ones like that are non-C functions on the left. Okay. So we'll do this derivative of our sine of u.
So it's probably lower.
And then you're just gonna, sorry, cosine. We're gonna do this in alphabetical order, just like before. Now, look at the derivative rules here for a moment. What similarities do you see between all the part trig functions? Sorry, let me put it up here. What similarities do you see between all the derivative rules? Yeah, they all have u prime in the numerator. They all involve fraction. What else? They all have u squared, and they all have u, and they all have 1, right? They all have The same thing, it's just a different set of order. Now, let's do this. We know that they all have the same numerator, so we'll just start off with u prime up top. They're all positive, don't have to worry about any signs change. What's the simplest looking one here?
No, I don't go straight on that.
Arctangent, right? Arctangent has no minus sign, has no absolute value, has no square root. So start here. 1 plus u squared. Now, the denominator, what's the most complicated looking one? Yeah, arcsecant, right? It's so messy. It's got the absolute value, it's got the square root, it's got a minus sign. So let's move on to this one here. You start off with the messiest part that we don't recognize, the absolute value of u. Thank you.
It's all good.
Thank you for doing that. Absolute value of u. Now the next one is the square root of u squared minus 1. I think the thing that students struggle with is the order here. Right, which one comes first? The u squared minus 1 and the 1 minus u squared. They look so similar to each other. So the way that I remember it is I know that the most complicated looking one has a square root. It's got a u squared. It's got a minus 1, and the u's are next to each other. That's how I remember it. So if the arcsecant has a square root of u squared minus 1, then arcsine is going to be a different order. So 1 minus u squared. And if we can figure out these three, then we'll just copy the arcsine, the arctangent, arcsecant, and just put a negative in front of it. Okay, so again, let me run through that process again. First off, the numerator are all the same. Arctangent is the messiest looking one. It's got the 1 plus u squared. Arcsecant, arcsine are the most complicated looking ones, but they're also the ones that look the most similar to each other. We start with the arcsecant, absolute value of u, square root of. You know it's going to be involving 1 and u squared. It's got a minus sign, so it look a little different from this. And then the u squared minus 1. I know u comes first because the u's are next to each other. And if I can figure out the order of the u squared minus 1, I know my arcsine is going to be different from this order. So therefore, square root of 1 minus u squared.
And you ever ones are just the negative.
That's right. And these I can just copy down the exact same as the one to the left. I just put a negative in front. So I think that's my way of memorizing the rules. Starting off with what's similar and then kind of figuring out what the differences are with the denominator.
Why is the sign, because I know it's like an inverse trig. Why is the sign related to cosine instead of related to cosecant? Because I know cosecant is the inverse of.
Right, it's the inverse, but the inverse, well, the reciprocal and the inverse have a different relationship, right? So that's what we're not going through the proof of why the derivative rules are the way they are. We just have to kind of be responsible for them. So I would like for us to try. I think we're going to skip page 1. We're not going to do these problems here, but I would like for us to try these rules again. So can you guys write down these and attempt? I would like for us to try this every day so that we can kind of work towards memorizing these rules. So you cross off 1 and 2. We're not going to do these on page 1. copy these down and I don't expect you guys to, get everything right the first try, but just see what you can remember from what we discussed.
So for test, we can have it, we're gonna show it like that, like. So you said we didn't memorize it, or are you just gonna say like, this is on the board right now?
I'm not gonna put this list on the board, but most of you guys knew the order from trig functions, so you're just gonna do the same thing with your trig functions, just put an arc in front of it, so.
Okay.
You guys know what the order is from, you guys proved that ability on the quiz, so just put an arc in front of it and you're gonna follow the same order, right? All the C functions in alphabetical order, sine and cosine, tangent, cotangent, secant, cosecant. Again, these are the only three unique ones, right? You don't want to fill these out, you don't have to. It's really these three that I want us to practice with. All right, go ahead and check your rules. If you didn't get everything right, it's okay. We'll practice this every day. I think 5 days of this, you guys will be able to get this down if not already. So yeah, seeing all the similarities between the three our trig functions, I think will help us formulate the rules a little better. All right, so if you guys can go to page 11, we're not going to be able to get through a full problem, but I know the types of problems that's going to require the most practice is always the curve sketching problems. I'm not going to give you any ones involving tangent or anything besides sine and cosine. So go ahead and cross off this one here. And I want us to do one similar that we've seen in the past. That's right. I always will give you intervals so that you know where the endpoints are. Okay. All right, so we know that everything is going to come from initially the f prime and f double prime. So let's start off with that. F prime. Okay, x minus 2 cosine x. X becomes cosine becomes find critical points by setting f prime equal to 0. Solve for x, or solve for sine x. Subtract 1, divide by 2. All right, where is sine going to be equal to 1/2? Right, which family here? 5 or 6, right? Right, but which quadrant are we looking at for sine? Third and fourth. So x equals. Good. But we have issues with the fact that these are both larger than pi. So what can we do to get to something that falls within the interval that we want? Subtract 2 pi, yeah. Right, we can place both of these onto our sine lines. You guys can put this in your calculator, but we also know that I want you to test one of them, and then all the other ones will be alternating in signs. Easiest one that I see is between -pi/6 and pi, which is 0. Where can I test 0 with? F prime. What's 1 plus 2 sine of 0? Positive or negative? Positive. So if this is positive, then this must be negative, and this must be positive. Right? What do you expect at -5/6? Well, relative, right? Relative max. At -5/6, you expect a relative min. If I want to find those ordered pairs, back into the original. Okay.
You test for like between -5 pi and -pi.
Yeah, it's hard to find one, but I would say just test one of them, and then you know that all your other signs are just going to follow a different sign, follow a different order here.
So alternate.
Yeah, they're the ones I give you will always alternate. So I know some of them are hard to find, but there's going to be at least one that's going to be easy to find, or easier. Okay, cosine -5/6. If you don't recognize that, think about where it's coming from. -5/6 came from what? 7/6. What's cosine of 7/6? Yeah, it'll be in that family, right? But it's gonna be negative in the third quadrant. I just want to see the exact value. You always use your calculator later to figure out where it goes on your graph. So we know that this is the order pair for my relative max. Okay, go ahead and find your relative min, and then we can pick this up tomorrow. Okay. Negative pi over 6 came from 11 pi over 6. What's cosine of 11 pi over 6? All right, positive, right? Okay, we got a full order pair for relative minimum. We got full order pair for relative max. What's left to do is to find the second derivative, concavity. Okay, we'll pick that up tomorrow. We covered all the new concepts. We're just going to, I have a test review packet for you tomorrow. We're just going to run through those problems. And I hope to give back your quizzes, if not tomorrow, then Wednesday. All right, come get your phones.
Given this for the related rates. I'm sorry, given it for the related rates.
Yes.
Are they pretty straightforward? Basically, like the same process as before.
Yeah, I can go through.
How's your weekend?
Good. Yours?
Good. You're gonna never do it. No stress of the bills this weekend.
No stress, that's right.
The
It didn't lose.
Chiefs lost their play next week, so that's kind of scary.
Oh. Chiefs lost.
They're gonna really want to beat us now.
Huh?
They're gonna really want to beat us now because they lost.
That's true, that's true. Let me show you.
So they're all gonna be like right angle, right triangle.
Exactly, right. They're all gonna be right triangles.
So no more like cones.
Right, no more cone problem.
I go to an answer and you go, nah, that didn't happen.
Okay, let me show you this example.
Why is he?
I'll give you this copy that you can take with you here.
Okay.
So let's say we have a right triangle here. You see how the fish, well, the pole is going to stay constant, it's 15 feet. But the fish is being reeled in, so this distance is decreasing, this distance is decreasing, and theta is changing as well.
I thought it started where Z was, and it came into 15 feet.
Right, right. So let me draw the variation of this triangle here. Okay. Now, we're trying to figure out what the theta dt is. We're trying to find the rate of change, but we have to first get to our Trig equation. Which Trig equation will allow us to get theta dt? Okay. Sine, cosine, or tangent.
That'd be sine.
So you would say sine of theta is equal to. Okay, we want to find the derivative, but that we prefer not to go through quotient rule, so we bring that z up. Find the derivative, what's cosine? Now, this is related rates here, so every derivative is going to have a g over dt after it's said and done. What's sine's derivative? Cosine theta.
Cosine data. D data.
Right. Okay. What's 15z negative 1?
That'd be negative 15. Raised or to the negative second power.
Times. And every variable has a
Oh, D data.
Not D theta, but D
Easy.
Z.
Yeah.
So d theta dt is the rate of change of the line or the, so we see that the fish is being reeled in at a rate of 1 foot per second. So d theta dt is -1, so we have this value. When there is total of 25 feet of line out, so that's the Z. So we're trying to solve for d theta dt. The only thing missing is this cosine theta. We don't know what theta is, but we can figure out what cosine of theta is equal to.
Yeah, but it, like, diagram pyramid.
Pythagorean theorem. So we're gonna step off to the side. Let's build a triangle with just numeric values. So we know this is 15. We know Z is 25. And the Pythagorean theorem will tell us that this missing side is.
Okay.
Therefore, what's cosine of theta?
Theta is 20 over 25.
Good, 20 over 5, which can be supposed to be. And that's it. So we have 4/5. We have d theta t. We have Z. We have d theta t. And then the rest of it is just like algebraically trying to skip d theta t by itself. And then,
So you always consult anything now?
yes, the ones I give you, we always solve.
Okay. And for this,
Always start with the trig function, find the derivative. If d over dt shows up, you use a triangle to figure out the ratio of your resolve your remaining trig function. And you replace that.
all right. That one, like the gallery value, so
I'll give you one to that.
okay, so that one's gonna test.
No. You take this.
Oh, thank you.
Okay, thanks.
You know what? What did you do on Friday?
Why?
It was,
You learn.
There you go. Thanks for the comment, I appreciate it.
Oh, yeah.
Thank you, man, I appreciate it. I got my Eagle Scouts, so
Congratulations.
thank you. I've been in that program for 11 years, you know, since first grade.
Yeah, so hopefully you can encourage some of those who in future years who are trying to get their Eagle Scout, be like,
Yeah.
hey, this is what I went through and this is what it takes to get there.
Yeah.
Congrats.
Thank you so much. It's like you're always an Eagle Scout, like it's not, you never were.
Right. So sure. Yeah.
Thanks, Sharon.
I did this in recording until 6th grade.
Yeah, I want you to leave it in that same. I think it's stand.
2.5 hours.
I think it was probably on accident, but you entered one of my post grades as a 10.
Oh, sorry. Sorry. Thanks.
Trying to grow it out. That's just not very How'd you doing? That's been your job about like at least. There was some good grabbing there, but I spotted them. Yeah. Like one of those tracking the first question. Study spelling was on the yeah.
Hey, Jackson, it's Big Fox. Sorry about that.
People just speed so they're not actually. What are you doing? That's it.
Masking yet. Oh. Exactly. Oh, yeah.
Six masters. I just do less time because there was years ago. I didn't show you. That's why I'm saying like, well, you first on that. Sure thing or whatever, like a cardboard. The 50 years old, you got an advisement. I absolutely. How's it gonna be? My friend, most of my friends are studying always also writing. That's just concept. Radius, like one. The one of them, I like. Was like, I mean, like, you take a. It's just like concepts. It's not a problem. They said it was that simple. But I think it depends on what the game does.
Friday, I think there was, maybe there was something on Friday.
Oh, yeah. Right.
Yeah, that's. I'm not so right.
You get your. You don't do it for now.
Right, this one. I looked it up.
I did do.
Okay, so, if I go around and check your homework, we did page 1730 in class, so I want to see that, and then also page 1920, from your back.
How's that saying?
What do you got?
Like so that. Like 5 minutes. Yeah. Okay. That's. I can. Yeah. I like to.
I'll let you listen to it.
I didn't know it's that, but it's just made of scratches. That's no clue. Yeah, I used to definitely like my mind. It's light. No, okay.
Oh, that's congratulations on your. I got it. That's like you got like 5. If you got 5, you can have it. Because like we're just great. You just start to fix it. And then each question is like all the things.
Wednesdays.
Okay, that could.
I mean, like,
Says like, there you go. This one.
Right before body. Right as it's. How do you say?
Is there anything? I thought it's because like maybe I like to pay attention. Dang. That could actually part. Like I don't know what I got, but it's like you can let me from 75. I was probably going to place it. You know, like I wouldn't. I wasn't. It was like. That would be for like okay stuff. So it's gonna let me recover, and they have like three marks. Oh, one of them is quiz. But it should be free. I don't know. It's just it's like
Name is kind of weird. Well, I won't call us bad. I think it's definitely. Like, give it a choice. The thing is, that's pretty much just. You got you. I don't get it. Something's like it's and then also I joined the board. It's not that's like under two. What is it?
Oh, yeah, that's another one.